Alright, hello everyone. It's March 30th. Alright, let's do this. I just watched 2 fights on NBA games. Things are absolutely crazy. People just like to fight, huh? They just like to fight and fight and fight. Alright, what's this one? Put marbles in bags. Or K bags are given a zero-indexed integer array weights and where weights I is the weight of the ith marble. You also give an integer k. Divide the marbles into k bags according to the following rules. No bag is empty. If the ith marble and jth marble are in a bag, okay, if ith and jth are in a bag, then all marbles with the index between should also be in the same bag. If a bag consists of all the marbles with an index from I to j inclusively, then the cost of the bag is the 2. The score after distributing the marbles is the sum of the cost of all the k bags. Return the difference between the maximum and the minimum scores among marble distribution. The maximum and the minimum. Do we have to get all the marbles? No bag is empty, but I don't think it's necessary for all the marbles to be in, right? So just like a range, like a subarray, right? So you divide it into subarrays, into k subarrays. No, not necessarily, because okay, I don't know if all the things need to be in order. Divide the marbles into k bags. Okay, I think it's all the marbles have to be in the bag. So basically we want to divide the weights, the array of integer, into k subarrays, right? K subarrays. And no bag is empty. Alright, so we have to find all different distributions. And the score is the sum of the cost. So each distribution has a score, right? So in the example here is 1, 3, 5, 1. So I can do 1 and this will be 1 plus 3 plus 1. Oh, 1 plus 1. Ooh, 6. So I can do this and this. That's 1 plus 3 plus 5 plus 1. Right? That's 10. Or this and this. This is 1 plus 5 plus 1 plus 1. This is 8. That's it. So the maximum and the minimum is 4. Huh. So we have k bags, right? Essentially you say we're picking k minus 1. Right, we're picking k minus 1 indices. Each one will produce a value. Yep. So, and if I say I have I, it's like k minus 2, right? So essentially all we have is w0 plus wi0, wi0 plus 1, wi1, ik minus 1, I call n minus 1, right? So essentially it's w0 plus wi0 plus wi0 plus 1 plus w1 i1 plus wi1 plus 1 that's k minus 2. That's not true. It should be k minus 2 plus 1. Right, so wi k minus 2 plus wi k minus 2 plus 1 plus wn minus 1. This is the total, right? And for each one we have a pair. And the end. Can the end be the same as the start? No. If the end is the same as the start, that become empty. So the end at least is one more bigger than the previous. And we want to find the minimum and the maximum. Well, maybe we can go look for the minimum, look for the maximum, right? So yeah, let's say we find a minimum and we go check how many or where did the minimum reside inside. So each one will represent one partition. When it came out as one partition, so we will find the minimum, how many, and a second minimum, right? So basically we have the minimum, have the second minimum, so we can sort it, right? We can sort it, or we can just use a map, right? Order map, and then we can get the smallest. So we get a smallest. And for the smallest, we can, look for where they are. And the start and end will exclude. Okay. So we find how many they are. And then we find the second one, we see how many they are. Right, and then they cannot be on the same, so I have to, which is fine. Right, which is fine. So in this case, I basically have 1 is at a 0, 0, 1, 2, 3. 3 is at 1. 5 is at 2. Right. So I look for the smallest. So the smallest, I go from here, I check the front, check the end. I don't have anything more. Right? Because the front and end both cannot be used. I need to find in the middle. I need to find in the middle k equal to 1. So I need to find a 1. So I go 3. So minimum will be 3. We'll find a 3 in the middle. Right, 3 in the middle. So the answer will be 1 plus 3. So whichever we find. But it's gonna start from. Hold on. Yeah, those are. We're gonna take the next one. That's actually not right. Because this is taking 3. Right, you take 3 and then you get. I don't know. Any hints? Yeah. Priority queue. No idea. Always simple. L is greedy. Okay, 4 marbles and 2 weights, right? Yes, 3 splitting points. We're there. Yes. Yes. we're very close, but didn't think about this. Sort based on this. Oh, holy crap. We're close. We're thinking about this, but yes, it's just the sum of this, right? The sum of this, the sum of this. So I just find the consecutives, sort based on them. Then we get the smallest. Then we get the biggest. Okay. Oh, we're close. This one, we're very close. We're almost there. Alright, so basically we need a vector of pairs. Nope, let's not do pairs. To make everything easier, we'll do this. Pairs, right? And then for, what do we put in there? Oh, we just need to put the sum. We don't really care. Right? We just need to put a sum in there. Okay, can we pick, hold on. So what we're doing is I do a, this cannot be the pair. So the pair is going to be this. This should not be involved. Because this, we have to use this. No, you can. This, and this, right? So can I do A0, A1, and then A1, A2? I don't think so. Because if you pick this, basically you're saying it's going to be A0, A0, A1, and it has to be something else. So it cannot overlap, right? It cannot overlap. So I will find, so if the second pair, right, if the second pair happens to be, so like this is a pair, and the second pair happens to be this, third pair happen to be this, then this one has to be skipped, right? Because you pick this one, I cannot pick this one because they cannot overlap. So I have to pick the second one, right? I pick this. So basically the question is, can we do greedy like this? I just take the first and then take this. Let's say we can get a better deal by taking this. But if I take this, I cannot take this, nor can I take this, right? Then I have to take something even bigger, so it's not as good as this. So yeah, so I think that's the way. And how many do you take? Well, that just represents this is the end of the previous, this is the start of the second, end of the previous. So end of the previous starts the second, so I need to pick k minus 1 of this, right? So in the example that show, so basically I have 1, 3, 3, 5, and a 5, 1. Okay, so if I do my array, it'll be 4, 1, 3. Actually, I will do index. 4, 0, 1, 8, 1, 2, and 6, 2, 3. Sort, so it's this, and this. So for the smallest is going to be this 4, but we have to add the previous at the end. So plus 1 equal to 6. But the largest will be this, will be 8 plus 1 plus 1. I don't even have to, because I have to plus these 1 anyway. So the difference is just going to be the largest minus the smallest. And the smallest and largest, like if I pick this, I cannot pick this, I have to pick the other one. Okay, so I do have to be a vector of this, and then we'll go from I equals 0. So hold on, let me put this one here. Oh, very close to solve. 2551. But I count it as a fail. Although this counts as another fail, we're very close to solve it. I realized that to make k subarrays, we need k minus 1 breaks, and each break consists of 2 adjacent numbers in weights. But that's where I got stuck. The trick is to sort all adjacent pairs based on their sum. Then the minimum way of partitioning the subarrays are the smallest, are the sum of the smallest k minus 1 pairs. So I note that no 2 pairs can share index. Similarly, the max way of partitioning is the sum of the largest k minus 1 pairs. Yep, that shall be good. Okay, so what do we have here? We'll have pair stop push back. Weights I plus weights I plus 1, and we have I and I plus 1. So in this case has to be minus 1, so we don't get out of the way. Alright, so we get it. So we get pairs, and then we're gonna do sort pairs dot begin, pairs dot end. Right, we sorted small to large, and then we say int long min sum, min score, okay, and then max score. So min score will be go from left to right, and then we want to find the first k, right? So I need to say count. The count is 0, and then for int now I equal to 0, I smaller than pairs dot size I plus plus, okay. we also need a pre-end. Okay, so pre-end equal to -1 to make sure, right? So we say if pairs I1 is a start is larger than pre-end, right? That they do not overlap, then we say min score plus equal to long pairs I 0 count plus, right? This and count is smaller than k, right? So now I have 1, I have 2, now I have k, we'll get out. And if it's not, if it's like equal to, then we don't do it. So this is to get the smallest, so I can do the same thing. So pairs dot size -1, I launch equal to 0. Now we can reset, count to 0, and then count smaller than k, minus pairs I right to left, so it'd be 2, right? It has to smaller than pre-start. No, not pre-start, post-start. Post-start shall equal to int max. Alright, so if it's smaller, oh, I have to update. Pre-end shall equal to pairs I 1. Right? Nope, that should be 2. Then max score is equal to long pairs I0 count plus post start shall equal to pairs I1. Right? So if it's smaller than this, yeah, then there's no overlap. And at the end, we'll just return max score minus min score. Okay, let's see. Is that working? Should be k minus 1. Yeah. Nope. All right, let's see. So we have 0, 1, 2, 3, 4, right? So we have 5, 0, 1, 6, 1, 2, 7, 2, 3, 7, 3, 4. That's it. And take 2. So the smallest, so it'll be 0, 1. So we can have 5 plus 7. Right, as the smallest. Bigger, we have 7 plus 6. So the output is 1. but expected is 3. How? How? What if I have 2 on the same thing? Is that possible? It will start at this and end at this. Maybe it's possible. Can I do, I don't know, 1, 4, 2, 5, 2. Oh, there's another one. So it's actually, hold on. That's 14. It doesn't work. How do you get 3? Okay, so hold on. We have to do 0, 0, right? Yeah, so we do this. Wait, hold on. So you're saying it's actually 5 plus 6 and 7 plus 7, because this is 11, this is 14. So difference is 3. How do we do 0, 1, or 1, 2? Oh, we do 1, that's 0, 0, 4, that's actually 0, 1, and then 1, and then 2, 5, 2. So it is this. And the big one is going to be 2, 3. 2, 3. So it'll be ending at 2, 5, 5, and then 2, 2. So it'll be like this. Alright, so it'll be 1, 2, 5, 5, 2, 2. So essentially we have a 5, 2, another 5, 2. There's no, we can't overlap. They can share. I can do it even easier. don't even need this, so yeah, because 0 is smaller than k. So min score max score. I think I directly do this plus equal to long pairs. Oh, actually make it much simpler. -1. Why is it so bad on the performance side? Don't know. In that sense, yes, we don't even need to create. Oh yeah, you're right. Because it's not very useful. It's still pairs. I think if I had my mind be a little bit clearer, I should have been able to make the connection. But today it was still not very clear, so I was not able to make the connection. Alright, that'll be it. I'll see you guys tomorrow. Adios.